Now again we will do an advanced level problem. And here again we need to find the equivalent capacitance of this configuration. The configuration is in your figure. This is again a problem of Irodov, and you have to solve this. 3.113 Irodov. Question number B. We will again use this our earlier concept to solve this. So here I have drawn it in my figure, in my copy. This is your x and this is your y. This is your x and this is your y, and plates 1, 2, 3, 4, 5 and 6. So we have to draw 6 plates: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Clear? Now you can see from the figure 1 and 6 are joined. So we will join again here. 1 and 6 are joined. 1 and 6 are joined. And we have to find capacitance between x and y. So x is between 2 and 3. So x is in between 2 and 3, and y is between 4 and 5. So one is x, one is x, this is x, this is x, and this is your y. Let this be positive, x be positive and y be negative. So since this is connected to source, so both will be positive and both will be negative. So 2 and 3 is positive. So 2 is positive, 2 is positive and 3 is positive. 3 is positive. And 2, 3 positive, 4 and 5 negative. So 4 is negative and 5 is negative, confirm negative, and rest of the plates will be induced. So if this is negative, this has to be positive induction, plus minus, minus plus, plus minus plus, and it has to be minus induction. Clear? Now from x, let it be x end, and let this be x end, and from x end we can see 2 plates, 2 and 3, x plates 2 and 3. From x plates, one is 2 and another plate 3. From x plate you can see 2 plate 2 and 3, and opposite to 2 there is 1, and opposite to 3 there is 4, and both 2 and 3 are positive, and one has to be negative, and your 4 has to be negative. So let's check here. 4 is negative, sure, and 1 is your joined with 6. 1 is joined with 6 and having positive end. So your 1 is joined with 6. 1 is joined with 6. You can see here clearly. 1 is joined with 6. So 1 is joined with 6. So this is a 2, 1, and 1 is joined with 6 and having positive. So opposite to 6 there is 5, and it has to be negative. So positive, negative, positive, negative. And your 5 is joined to 4. 5 is joined to 4. So your 5 is joined to 4. 5 and 4 are joined. So 5 is joined to 4, and between 5 and 4 there is y. So between 5 and 4 there is y. So this is this was your actual figure, and from that we reach to this figure, and from that we reach this figure. Now what we got, okay, 2 capacitance are in series and third one is parallel. If C, both are C and C. So 2 are in series. So C in series, so it will turn to C by 2. So it will turn to C by 2. C are in series, and this is in parallel with another capacitor C. So when they are in parallel, so they will just add up. So C plus C by 2 is equal to, so C equivalent is equal to 3C by 2, and that's your answer. So for this configuration, your answer is 3C by 2, and how it reached, you can rewind it and you can observe it, how the plates are arranged, how the point X and Y are noted, so that we can find equivalent capacitance between these two terminals X and Y, and how this X and Y is placed in your second figure, and how these total calculations are we achieve the result using our concept. So this is a problem of little bit higher concept is required, depth knowledge is required, and this way we solve all these capacitor problems. So we will solve few more problems. We will solve few more problems. Okay.